Hey, good afternoon. Jason Williams here from the East Anglian Astrophysical Research Organisation. Happy New Year to everybody. Welcome to the first of our live streams from our Space Operations Centre here at Alconbury in Cambridgeshire. Today we're going to be observing the Quadrantids meteor shower. So today the Earth is ploughing through debris left behind from the orbit of an asteroid called 2003 MH1, asteroid 2003 MH1. And we're using radio techniques to listen to the reflected radio signals from Meteor tails, so to speak, as meteors enter the Earth's atmosphere above France and Belgium. So today we're observing over France and Belgium. So as a meteor travels very fast through the atmosphere, it superheats the air behind it. And those lovely tails that you see when you see a meteor actually, for a very small amount of time, turn to plasma. And that ionised air, that plasma, reflects radio signals very well. So we can send lots of radio signals up into the air. The radio signals reflect off of those lovely, beautiful trails, and then are received back down here on Earth using our radio receivers here at Aero. So we don't necessarily need to have clear skies. It doesn't even need to be dark. Because we're using radar, we can see those signals electronically with our instruments here. If you look on the screen above me, there are three large screens at the front of the control room. The screen on the left is our Brahms Meteor radar system. So there we're listening to reflections over the south of Belgium using a transmitter called the Dorbs beacon. The screen in the middle is our tracking screen. There we can see where the stream of the Quadrantids is in the sky, and you can see to the screen on my right, you'll see a little circle, and that little circle shows where the stream currently is above the horizon. So it's in a really good place there for receiving reflections. That's just to the northwest of where we currently are at Alconbury. And then the screen on the right of the control room is basically showing our radio results or our meteor reflections from Graves. I can switch over to Graves and you can see how active Graves currently is. It's just coming up now. There you go, there's our Graves reflections. The Quadrantids is a very, very high yield stream. Currently we're seeing approximately 1 meteor a second using our very, very sensitive radio telescope here. You can see every one of those yellow streaks is actually the reflection of the trail of a meteor as it enters the Earth's atmosphere. Most meteors we observe are probably only about the size of a grain of sand. We call them micrometeors, but they're moving extremely, extremely fast, producing a lot of friction as they enter the Earth's atmosphere, and that heat that they produces these lovely trails behind them. Those trails superheat the air, which turn into plasma just for a short while, but it's long enough for us to reflect a radio signal off the trail and receive it back here on Earth. The signals we're receiving are probably somewhere around 1,700 kilometres from here, and most of those meteors, as I said before, are about the size of a speck of sand. We're actually very lucky to have Adam and Zoe here today. So Adam Morgan and Zoe Wheelwright are from Cambridge Regional College. They're a couple of students that are using the Quadrantids observation today as part of a maths project to work out some quite interesting statistics. So they're going to be observing the Quadrantids meteor shower from this afternoon and all the way into the end of tomorrow evening. And they're going to take that data, which they're going to record from Belgium and from France, and then they're going to count the number of reflections they can see over certain time periods. So we're quite excited to have Adam and Zoe with us. Due to the COVID-19 restrictions, they're not here in the control room today, but they've actually logged in from home. If you look at the waterfall display to my right here, and look at the very top of the screen, you'll see a little red flashing light. That shows that Adam and Zoe are logged in and currently recording data today. So really great that we've got some really good use for the data that we're receiving in the skies for the Quadrantids meteor shower this afternoon. Thank you to everybody who's joined us. I think we've got 6 viewers on this afternoon. I'm really sorry that I advertised this event very short notice, but we're really pleased to have a number of you joining us throughout the rest of this afternoon. We're probably only going to be streaming up until about probably somewhere around 6 o'clock. But I thought it would be really nice for a change to do an afternoon observation. Most of the observations we do are either late at night or very early in the morning, and some people just can't watch during those times. So really pleased to have you all with us. Thank you very much indeed. Special hello to Benny, my wife, who's joined the stream this afternoon. Also to SDR Musings and to David Moore. I can see you all there in the chat box. Thank you very much. For any of you who are new to ERO, we are the East Anglian Astrophysical Research Organisation, commonly known as ERO. Our objective, as you can see probably on the wall behind me, is to inspire and educate people through meaningful space research. So our aim is to make astrophysics accessible to anybody who's interested. Whether they be young or old, we have a volunteer scheme where people can join as part of our team and come and help us here at the control centre and with a number of our experiments. We have a junior team where youngsters can join us, and we give them each an experiment of their own to basically operate and to observe. And then recently we started a supporting members scheme. So if you go to our Facebook page, East Anglian Astrophysical Research Organisation, pinned right to the top of our posts is an application form there where you can actually join and become a supporting member of ERO. So if you haven't got time to come and volunteer your time here, you can pay just a small membership fee each year and still be part of our team. So you'll get regular newsletters. We'll invite you to some special member events, be it most of those are currently online due to COVID. But nevertheless, you'll be very much welcomed into our organisation as a supporting member. Also, we have a website, www.ero.org.uk, where you can learn a lot more about our organisation and our mission and what we do. There's also a really cool merchandising shop on there. If you click on the little picture of the t-shirt, you can buy these really lovely ERO t-shirts, and I think we've got some hoodies for sale and some posters and various other merchandise if you're interested in that. So I say we're here today for anyone who's just joined us observing the Quadrantids meteor shower. Now meteors enter the Earth's atmosphere all the time. In fact, there's probably about 20,000 tonnes of debris that falls on the Earth every year. Not all of those meteors come from showers. There's all kinds of debris in space raining down on us all the time. It's just that we choose to do the observations during the meteor showers because there are many more meteors, because we're ploughing through those streams of either comets or asteroids. Today's stream, the Quadrantids, has been produced by the debris from an orbiting asteroid called asteroid 2003 MH1. And basically, I think the way to think of it is if the planet Earth was a car, and you're in your car, and there's a really heavy snowstorm. When you're driving into the centre of that storm, that's when you get most of the snow kind of hitting your window. You've got your wipers on trying to clear it off. If you can imagine planet Earth as the car, and us ploughing or driving into that storm, around sort of 2:30 this afternoon, in about 15 minutes, we'll be right at the peak of that storm, and we should see an awful lot more reflections. So currently you're looking at graves on the waterfall there, and those orangey yellow streaks you see, every one of those is the reflection off the trail of a meteor. We call them micrometeors because most of the meteors that we receive are really only about the size of a grain of sand. I'm just going to show you a different screen, which is our observations using our Meteor radar system over Belgium. We use a transmitter in Dorbs in the south of Belgium. I'm just going to show you what that looks like. You can see a huge reflection there, just about to disappear off the bottom of the screen. By the way, while we're on this screen, the kind of fuzzy background that you can see, kind of the blue and purple dots, that's basically what we call galactic background noise. So most of that is noise produced from something in space. It could be hot gases, could be cold gases. There's lots of things in space that produce noise. Actually, as well as on Earth, we make a lot of man-made noise. Anything electronic or electrical, be it power grids or mobile phone towers or people's car engines. Everything makes some sort of electromagnetic noise, and that purpley, bluey stuff that we can see in the background is noise. It's a bit like if you tune your old FM radio in your car, and you tune it out slightly and you hear all that in the background, also known as white noise. That's basically what you're seeing here. So we're looking at trying to pick signals out of that noise, and we use some very sensitive antennas, some equally sensitive receivers and preamps, and then we use some very special software that performs something called FFT, which allows us to see the frequency of the signals that we're currently looking at now. You can see some of those little streaks just coming down the middle of the screen. They're all very, very kind of faint reflections. The transmitter that we use in Belgium is only about 150 watts of output power, but we do generally tend to see some really great reflections coming off the system that we use for Belgian reflections. It's a little bit weak now. It's almost the way when I show you a screen that it's not going to be quite as wow as it can be. Oh, there's another little reflection just coming down now, and another one. So it's been a very steady stream since I got here at about lunchtime, so a couple of hours ago. But I think you'll agree that we get a lot more reflections from our Graves meteor radar, which is basically set up so we're probably looking at meteors coming in over the area of the Pyrenees Mountains in the south of France, which is about 1,700 kilometres from here. There's a really interesting reflection there over Belgium. Just going to switch back to Graves. See some really interesting reflections there. Again, you have to remember that most of these meteors, or most of the reflections that we're receiving, the reflections are from the tail of the meteor rather than the actual meteor itself. The meteor is only about the size, generally, of a grain of sand, but we're interested in reflecting our signals off the trails of those meteors. Occasionally, if the meteor's bigger than a grain of sand, you will see a head-end reflection. So occasionally we'll get what's called a fireball, which is a much larger meteor. Some of those meteors don't actually completely burn up in the atmosphere and will actually fall onto the surface of the Earth and become a meteorite. And if you're lucky enough to find a meteorite, these are very rare and can be worth an awful lot of money. So there you go. If you ever see something heading towards the ground, then you should absolutely go and look. It will either be a meteor or a UFO. So there you go. So there's reflections there. Some really nice, strong reflections coming from our transmitter base over in France. Let's just have another look at Brahms. You'll notice how the streaks look very different. That's because the two transmitters are different frequencies. So the transmitter that we're using for Brahms transmits at around 50 megahertz. So those waves are about 6 meters long. And the transmitter that we use over France transmits at about 143 megahertz, which is in the region of about a 2 meter wave. So obviously different waves have different properties. We're using different antennas, slightly different receivers. So those pings will look very different. I'm actually going to turn on some audio soon, because we actually demodulate the audio from some of these signals that we receive, and they sound like very kind of weird, like Doppler shifted pings. So if you bear with me, I'm going to walk across to the control room and switch on an amplifier and a loudspeaker, and you should be able to hear some of these sounds as they ping through. So just bear with me for 1 second. Okay, I'm hoping you're going to hear some of these pings now behind me. The lower sounding pings are the Doppler shifted pings from Belgium, and the higher sounding pings are the Doppler shifted pings from France. They've got very distinctive characteristics about them. We've actually provided some of these audio pings to musicians in the past that have used them in musical compositions. So again, we're not just looking at this data, but we're actually using the data to do some really good things. If I switch across to our tracking software, you can see quite clearly there the source or the radiant of the Quadrantids stream, which is the little round circle just to the left of the screen. So if you can see where that kind of red and white kind of transmit tower is, just to the right of there you can see that circle, which is the Quadrantids stream. You can see that's in a really nice position over the horizon for us to get some great reflections from the radio transmitters that we're using. So that's, you can see, if you look, there's kind of a red line that kind of travels through the forest horizontally, and you'll see there's a little red end there showing north. So it's about northwest currently, that stream. The zenith hourly rate, or the maximum number of meteors expected to see in an hour, is somewhere around 120, but that's visible meteors. So we're not obviously looking at the meteors, we're listening to reflections. Some of the weaker ones you may barely see, or maybe behind cloud, etc. Sometimes we've peaked anywhere up to 1800 meteors an hour using the systems that we have here. So we've got some very, very sensitive antennas that form two extremely sensitive radio telescopes that we're using to listen to these reflections from the streams of micrometeors as they enter the Earth's atmosphere. Just head back to our brown screen in Belgium. I hope you can kind of hear that reflection that's currently behind me. Just switching our control room cameras so you can see a better image of our control room here at Alconbury. We're actually based in a Cold War bunker on the former RAF Alconbury airfield. This is in fact the area of RAF Alconbury where they stored the nuclear ammunitions over the war. Wow, that's a really, hope you heard that kind of really strong ping behind me. Yes, as I was saying, our Space Operations Centre here at Alconbury is based in a bunker. It's actually an overground bunker, a bit like a fortification. You can see the concrete, the very thick concrete roof above us. There are no windows in this building, only small gun slots. You can see one is open just to the left of me behind this screen. We've been here just over a year thanks to the developers Urban and Civic who gave us our home here. We're really grateful to them and for the good people of Alconbury World for accommodating us. It makes a really good control centre. It's very secure. We're very well protected here with some great security. So we're kind of really pleased to be here, and you know, a really good use for something that otherwise would have basically just been destroyed. Look at that huge, great reflection there. It's probably something a little bit bigger than a micrometer, I would have thought. Occasionally we will get an aeroplane fly through our detection area, which can sometimes produce reflections like that. But I think what you might be seeing there could actually be what we call a fireball, which is a much larger meteor, much larger than a grain of sand. That one could actually turn into a meteorite, i.e. the debris could actually fall onto the surface of the Earth. For someone to collect as a meteorite at some point. So we really like it when we get those huge reflections. That one sounds like one from Graves, to be honest. You can really see that the number of reflections is really ramping up as we reach the peak of the Quadrantids in a couple of minutes from now. So we're really kind of in the peak now. Really great that we're recording this data. We'll hopefully be showing you some highlights in the next few days once we've processed the data that we currently have. Okay, I'm going to take a break for a second to go and answer some questions. If anyone has any questions on the live chat, please, if you're new to Eero, you like what you see, you like what we're doing here, please don't hesitate in clicking that subscribe button. And also don't forget you can now join Eero as the supporting member. The best place to find the application form will be on our Facebook channel. And it's pinned to the top of our posts. You'll see a lovely poster there showing all the goodies that you get in your membership pack when you join. And we're offering a special price at the moment of only £29 per year. So please, by all means, join us and be part of our really exciting space research organisation. Okay, I'm going to leave you with a nice clear picture of the Graves screen, and I'll come back to you shortly. Hey, good afternoon. Jason Williams here from the East Anglian Astrophysical Research Organisation, or commonly known as ERO. We're currently observing the Quadrantids meteor shower this afternoon. We're currently in the peak of the shower, which peaked around 2:30 GMT or UTC. We're currently observing from our Space Operations Centre, based on the old RAF Alconbury airfield, just to the west of Cambridge. Thank to everybody who's joined us this afternoon. We're going to be observing probably through till around 6 PM this evening. We decided that we would have an afternoon observation. Generally we make observations either late at night or very early in the morning, but we thought we'd give people the opportunity that don't normally get to watch those very late observations a chance to have a leisurely Sunday afternoon watching our YouTube channel. You're currently looking at reflections from meteors somewhere over the Pyrenees Mountains in the south of France. Each one of those yellow streaks that you can see on the radio screen to my right is actually the reflection of a radio signal off the trail of a meteor as it enters the Earth's atmosphere. So as meteors enter the Earth's atmosphere, they produce a lot of friction, and that energy is given off as heat. The air is superheated behind the meteor. Generally most of these are only about the size of a grain of sand, but there's enough friction to produce these hot trails which actually ionise the air behind them, and that air for a very short while turns to plasma, which then reflects or acts as a really great mirror to reflect radio signals back down to Earth. So we irradiate the sky with lots of radio signals. We listen to reflections coming off the trails and the meteors as they spin down through the Earth's atmosphere. You can see each one of those little yellow streaks on the radio screen is a reflection off of one of those trails. So you can see just how active the Quadrantids meteor shower stream actually is around its peak time. But of course, you don't need a meteor shower to see a meteor. About 20,000 tons of debris falls to the Earth every year. A lot of it burns up in the atmosphere. Occasionally fragments will make it to the surface of the Earth, where they become meteorites, and if you find a meteorite, they can be quite valuable, as obviously they're quite rare. I'm going to show you the radar screen for the Brahms meteors. So these reflections look slightly different because we're receiving the radio signals at a different frequency from a different transmitter called the Dorbs beacon in the south of France, south of Belgium, I should say. But nevertheless, you can see quite clearly the reflections as they flow down the waterfall screen. The size of the reflection on the screen hasn't always got a bearing to the size of the meteor. So when you see a larger ping, it may not actually be a larger meteor. It's just the fact that the trail from that meteor is a lot more reflective to radio waves. So to answer David's question earlier, again, we can only kind of really approximate the size of the meteor using this technique. We don't know exactly how big that particular meteor is. But when there is a head-end reflection, so when we get a reflection of the actual meteor itself rather than the trail of the meteor, you will see a kind of lumpy reflection at the start of the signal, and it will kind of fade towards the end. We'll try and look out for one of those, and then I can show you what I mean. Hopefully you can all hear the pings behind me. I've just been told that my mic signal isn't really loud enough, so we're going to just up the signal a bit. There we go. Hopefully that's a little bit of a stronger signal from the microphone, and you can hear me slightly better over the stream sound now. Thanks SDR Musings for that bit of advice. Just going to mute that second microphone. Hopefully some of that echo will have gone now, Benny. Is that a bit clearer? Thank you all for the questions. SDR Musings, your question about the peak. I think that is an absolute peak, the 2:30 UTC. I think that's an absolute peak for wherever you are listening to those reflections. Sorry about the audio hiccup. Hopefully things are much clearer now. Lovely reflection there coming in over Belgium. Look at that one. Really interesting. You can see there the beginning of the signal is a lot stronger than the end. Generally that's because the plasma trail only lasts for a very short period of time and then kind of fizzles out towards the end. So you can see there on the waterfall display, towards the end of each echo it kind of fizzles out, and you'll see it just getting weaker and weaker until it suddenly disappears. Thank you to everybody who's joined our channel this afternoon. Really pleased to see you all here. We are ERO, the East Anglian Astrophysical Research Organisation. We're a not-for-profit charitable organisation with really just one objective, and that is to inspire and educate people through meaningful space research. We're involved in a number of projects, all currently at different stages. Our three main projects here are ERO Radar, which is our plans to build our own dedicated Meteor radar system on the island of North Ronaldsay, which is a remote island in the Orkney Islands, from where you can actually see the Northern Lights. It's a really beautiful place. Our second project is called Arecibo. Arecibo is our plans to build the UK's first SETI telescope and observatory. So this will be a dedicated radio telescope for the search for extraterrestrial intelligence, using a very novel strategy which is unlike any other SETI observation that has ever been carried out before. So very cutting edge, very much a different style of telescope, and something that you will be hearing about a lot more once our press release comes out in the next couple of weeks. And our third project is a project called AeroMine. It stands for Mini Neutrino Experiment, where we're basically looking at building some detectors called scintillators, which help us to observe an elusive particle called a neutrino. So neutrinos are produced as a byproduct of nuclear fission, and nuclear fission occurs in all kinds of big astronomical events. So things like when stars are born, when stars die, they supernova, when black holes collide, even from black holes themselves. And by observing these tiny little neutrino particles, we might actually be able to see some astronomical events that we haven't seen before. So there's a lot more to it than that with neutrinos, but that's kind of the simple explanation. So those big three projects that we're running here at Aero Radar, Aero Chibo, and AeroMine. If you go onto the Aero website and click on the merchandise store, you can actually buy a t-shirt for each project. So there you go, you should go online and collect all three. Please join us as a supporting member. If you can't actually get over and help us with some of your time by volunteering on our team, you can always join us as a supporting member. If you go to our Facebook page, and pinned to the top of our posts, you'll see an application form link. Please click on that and join, and be part of our really exciting space research organisation. I'll be really pleased to see you join and welcome you on board personally. Look at that fantastic reflection now from Belgium. We really have spent quite a bit of time over the last few months tweaking our radio telescopes here, tweaking our receivers, calibrating our software, to really show you, the best of the best reflections. I know there's a number of other individuals and organisations that share these observations, but of course we're trying to be the best that we possibly can. And obviously we're fully supported by you, so the more support we have, the much more interesting and more exciting we can make these observations. So please support us in any way you can, either by subscribing to our YouTube channel, joining us as a supporting member, following us on Facebook, Twitter, Instagram. Any support you give will be greatly appreciated. I'm just going to take a break, and I'll be back shortly. Good afternoon from Aero. My name is Jason Williams. I'm one of the directors here. We're observing the Quadrantids Meteor shower this afternoon. The peak was about 20 minutes ago, around 2:30. And we've got some really strong reflections coming in from both our Graves forward scatter radar system over France and our Brams forward scatter radar system over Dorbs in the south of Belgium. Thank you to everybody who's joined us this afternoon. We are EARO, the East Anglian Astrophysical Research Organisation, EAARO. Please go and check out our website. You can see the website address behind me, www.earo.org.uk. You'll also find us on all the usual social media channels. We tend to post quite a lot on Facebook, Twitter, Instagram. You can also find us on LinkedIn. Please go and find us, read about what we do, and please support us in any way you can, either by making a donation on our website, joining us as a supporting member, or just following one of our social media channels. Please also don't forget to subscribe to YouTube. We've got some amazing events, some really interesting observations lined up, and our Royston Observatory goes back online later this year. So we have a radio observatory based in Royston in Hertfordshire. We're basically in the shadow of the Cambridge University's Mullard Radio Observatory. And later this year we're going to be doing some fascinating observations from Jupiter. We actually observe Io, which is the closest orbiting moon of Jupiter, and we look at some very interesting electromagnetic effects which occur when Io is in its closest orbit to Jupiter. We're spending a lot of time at the moment building the observatory systems over in Royston. We hope to have that online later this year, so I expect to see some really fascinating live streams from Jupiter. We're also spending quite a bit of time on our Meteor camera system. We have 2 Meteor cameras here on the roof of the Space Centre. We also have a camera at our Royston site, and we're about to look at putting a new camera up on our site on the Orkney Islands. Using these cameras, we might actually be able to triangulate meteor positions as we see them in the sky, especially the ones in our local area, and actually provide a detailed location of where they are above the sky in the UK. So that's all going to be quite fascinating. We're also working alongside an organisation called UK MON, which is the UK Meteor Observing Network. And there'll be more news to come on that later in the year. Also hoping to get over to our observatory site in on the Orkney Islands as well, to continue the work that we're doing across there as we get closer and closer to building our Meteor radar system. You'll see information about all of these projects on our EARO website at www.earo.org.uk. Again, thank you for joining us this afternoon and for observing the Quadrantids meteor shower with us. You're currently looking at a radio screen from our Graves meteor radar system, and you're looking at reflections from the trails of meteors as they enter the Earth's atmosphere. We're moving off the peak slightly now, so we might get a bit of a reduction in reflections. You can see there's quite a lot of weaker ones coming down the screen. Let's go over and have a look at our Belgium results. And you see quite a few pings there still Lots of little weak ones, not quite as many strong ones as we had before. But the Quadrantids will go through right into the middle of January. But this is kind of the strongest. This is the strongest point, really, for getting the best reflections. Going back to our graves data, you can see currently this afternoon we're getting a much stronger, higher yield from graves than we are from the reflections that we're receiving over Belgium. Good afternoon, everybody. Welcome to ERO, the East Anglian Astrophysical Research Organisation. I'm hoping you're all enjoying these wonderful Doppler shifted pings that we're demodulating from signals reflected off the tails of meteors as they enter the Earth's atmosphere above the regions of both France and Belgium. The radio screen you're looking at now shows radio reflections from meteors somewhere over the Pyrenees mountain range, we think, in the south of France. Probably about 1,700 kilometres from us, which is about 1,500 miles, I think, roughly. So we use some very sensitive radio equipment. Some huge, great radio antennas called Yagis. They look a little bit like TV aerials, very directional antennas which are pointed towards this particular region of France where the Graves transmitter is. And then we listen to bits of radio signal being reflected off of meteors as they enter the Earth's atmosphere above the region of Graves, or actually probably about 100 kilometres south of Graves over the Pyrenees somewhere. Lots and lots of pings this afternoon, as we generally expect from the Quadrantids. It's quite a high yield meteor shower with visible meteors up to somewhere around 120 to 150 meteors per hour. So if it was really clear skies above France today, you'd be in for a real treat. There'd be shooting stars all over the place. We're just about half an hour off of the peak. The peak was about 2:30 this afternoon GMT. But still a nice steady stream of meteors still to be observed. And we're quite lucky to have Adam and Zoe with us today. From Cambridge Regional College, who are making their own observations using our data as part of some coursework they're doing. Really pleased that they're helping us with this afternoon's observation. As I said, the radio screen you're currently looking at is reflections from meteors over France. And then I can switch now so you can see our Belgium radar screen. And you'll be able to see one or two smaller pings there, which are signals reflected off of meteors entering the atmosphere above the south of Belgium. We use a transmitter called the Dorbs beacon, which was specially designed for meteor observations, whereas Graves is a totally different transmitter, which is part of the French military's air defence system. We're only interested in listening to reflections off the carrier signal. We don't receive any other data. We're just interested in the continuous wave tone that transmitter emits, and picking up reflections off of meteors as they bounce back those tones back to Earth to be received by our sensitive antennas here. Occasionally the signals are so strong that they produce a big blip right across our software. This one you can see that kind of long blue bar going across the screen. The signal just tends to overload the software very briefly because the signals are so strong at that point. Been a really, really good afternoon for a meteor shower. I'm sure you'll agree, and hope that you're all very much enjoying what we're showing you this afternoon from the comfort of your own home or wherever you might be. Look at those great reflections over the south of France this afternoon. Really, really pleased with the way the equipment is behaving and how our systems are holding up. Hopefully the live stream is also good quality. We only have a 4G connection coming in here, and we're sharing that connection across a multiple number of different internet-based systems, including the live stream. So it says on my YouTube control panel that the connection is excellent. So I hope you're getting the same quality on your PCs, tablets, phones, etc. And thank you all again for joining us. You're all very kind and always very welcome to join us on our observations. Good afternoon to anyone who's just joined us. It's Jason Williams here, Director of the East Anglian Astrophysical Research Organisation, or ERO. We're here this afternoon at our Space Operations Centre in Alconbury, Cambridgeshire, and we're observing the Quadrantids meteor shower, the peak of which was earlier this afternoon, about 60 minutes ago. Getting some really nice, interesting reflections off of meteors as they enter the atmosphere in both of our search regions, one of which is in France. You can see the reflections now on the radio screen to my right, and the other one in Belgium. Hopefully you're enjoying all these weird kind of Doppler shifted pings that you can hear. This is basically what happens when we demodulate audio, which is carried on the radio signals which are reflected off the meteors. And they appear to sound like these really kind of weird Doppler shifted sounds as the meteor produces this beautiful tail which reflects the signal and then disappears almost as quickly as it's made as the air cools behind it. You'll see some really big reflections and some very kind of weak reflections as well. These really don't have any bearing on the size of the meteor, more how reflective that particular meteor's tail is as it streams down through the atmosphere. These meteors, most of which we call micrometeors, they're not really much bigger than the size of a grain of sand, but they're travelling through the atmosphere with enough speed that friction is produced and they kind of superheat the air behind them, allowing us to bounce radio waves off these superheated tails. And as you can see, they're producing quite beautiful reflections, which obviously, using our observation techniques, you can see and you can hear at the same time. Good afternoon, everyone. Jason Williams here from the East Anglian Astrophysical Research Organisation, or commonly known as ERO. We're here this afternoon observing the Quadrantids meteor shower. We started about 2 p.m. Or 1400 UTC, and we witnessed the peak, which was probably around 2:30. Although saying that, we've had a really strong yield of meteors since I got here earlier to start setting up the observation around midday. So really pleased with the results of the observation. We're looking both in the regions of the south of France and the south of Belgium, which is where the transmitters are that we use. And then all the receiving equipment is here, where we're utilising our Meteor telescopes from the Space Operations Centre here at Alconbury in Cambridgeshire. We're based on the former RAF Alconbury airfield, and for our Space Operations Centre we utilise one of the former Cold War bunkers, which is actually on the part of the site where the nuclear munitions was stored here for 30 years over the Cold War. So between about the 50s and the 80s. Thank you to everybody who's joined us today. We've had a really steady stream of viewers. Hopefully you're enjoying the Doppler shifted pings, which you can hear where we demodulate the radio signals that are reflected off of the meteors that we're receiving. And remember, most of these meteors are really no bigger than the size of a grain of sand. We call them micro meteors. Just wanted to jump in and wish everybody a happy new year. This is the first of a number of observations we're going to be making this year. And watch out for some of our Jupiter observations, which will be going online a little bit later this year, where we're actually looking at an interesting effect that occurs when Io, Jupiter's closest orbiting moon, is actually in its closest orbit to Jupiter. That should be very exciting, and more news about that to come later this month. Please don't forget to subscribe to our channel, enjoy the pings, and I'll be back a little bit later. Good afternoon, viewers. Jason Williams here from the East Anglian Astrophysical Research Organisation, commonly known as ERO. Thank you for everybody who's been watching our stream this afternoon and for any new people that have joined us. We're currently observing the Quadrantids Meteor shower. We've been here since, we've been streaming since 2 o'clock this afternoon. The peak was about 2:30 and it got very active. But we still had a fairly active meteor stream throughout the afternoon. And the radiant from where that stream appears is still reasonably placed over the horizon to get some good reflections. It's getting a little bit lower now as the day goes on. I can show you where the stream is. So you can see the little red circle with the QUA inside it. If I just open that screen. We're currently observing meteors over France and Belgium. So the screen here, just popping up now, shows reflections from the tails of meteors as they enter the Earth's atmosphere somewhere above the south of France. Every one of those little streaks, and every time you hear one of those Doppler shifted kind of eerie pings, we're picking up the reflection of a meteor. Most of these meteors, incidentally, are only about the size of a grain of sand. We call them micrometeors. There's about 20,000 tons of debris that rains down on the Earth every year, and most of that debris are these tiny little pieces of sand sized particles, I guess you could say. A lot of them come from the debris produced by comets and asteroids as they orbit the solar system. See lots of pings there. Lots of interesting shapes as well from the reflections. This is the receive screen for our Meteor radar system that we currently use to monitor reflections from radio signals over the skies of Belgium. You can see that the pings are a lot less. It's a much lower power transmitter and also operating on a different frequency as well. This was very active earlier during the peak, and the stream is has reduced slightly, but we're still seeing quite a frequent number of reflections as we look above the skies in Belgium for micrometeors. France is obviously our strongest stream. So we hope you are all enjoying our stream this afternoon, our first meteor shower observation of the new year. I think we'll probably continue for about another hour and a half. We'll probably wrap up around 6 p.m. Thought we'd do an afternoon observation for a change. Normally our observations are either late at night or early in the morning. We thought it would be nice to do an afternoon observation for those people that can't join us very late at night to observe what we're doing here at Eero. And again, thank you to everybody who's joined us this afternoon. Please don't forget to hit the subscribe button so we can keep you up to date with all our future observations, especially during COVID. Pretty much everything we're doing at the moment is live streamed because we can't have public here on site in our control room here at the Space Operations Centre in Alconbury. Really strong reflection there coming in over France. Let's just have another look at Belgium. A little bit slower, but nevertheless still interesting reflections coming in from micro meteors somewhere above Dorbs in the south of Belgium, where the transmitter is. You can see those little orange flecks. Each one of those is the reflection off of a micro meteor. There's a slightly large reflection coming in now. You'll see the reflections don't last for very long because we're bouncing radio signals off the superheated air that comes in behind the meteor. The air turns to plasma for only a short amount of time, so we only get a very short reflection before the air cools and the reflection is lost. By about 7 or 8 this evening, the radiant is very low over the horizon, so that will really affect our reception of signals from the Quadrantids and for really any meteors that are entering the Earth's atmosphere above our search regions. It's a very strong signal there coming in from France. I shall leave you with the Graves meteor screen, just because that seems to be the most active at the moment, and come back to you shortly. Enjoy the stream. Hello, and a very good afternoon, good evening to all our viewers. My name is Jason Williams. I'm the Managing Director of the East Anglian Astrophysical Research Organisation. Here observing the Quadrantids meteor shower with you this afternoon. On my own, because we currently are under COVID restrictions. So really unable to have more than one or two people in our control room here at Alconbury. You can see a picture of our control room above me here. Just to my right is a radio screen showing radio reflections from meteors as they enter the atmosphere above a region of France, probably just south of a village called Graves, probably about 100 kilometres south actually, over the Pyrenees Mountains. We've had a really active stream of meteors today that we've been observing. Most of these meteors are only about the size of a grain of sand, but because they're travelling at such a speed through the atmosphere, they produce quite a bit of friction, and in the trails behind them, they actually superheat the air, which turns to plasma. That plasma reflects radio waves that we send up into the sky above that region, and we receive those signals reflected back to us here at Alconbury using some very sensitive antennas and radio equipment. So every time you see a yellowish streak coming down that waterfall display, you're actually seeing the reflected radio signal from a meteor. Remember, these reflections are from the trails of the meteors rather than the meteors themselves. We've had a real steady stream during the Quadrantids, which is one of the stronger meteor showers of the year. Sorry for the very short notice publicising this event. Again, that's just down to Christmas and COVID restrictions, etc. But I didn't really want to miss this observation because, as I say, it's quite a strong one. And the zenith hourly rate, or the number of meteors observed in an hour, is always predicted to be around 120 to 150 for this particular shower. So it's quite a strong stream. As well as looking at meteors coming in over France, we also look at meteors coming in over Belgium. I can show you the Belgium screen. We see a little less, or we see less frequent meteors over Belgium, and that's really just due to the nature of the transmitter that we utilise over there. It's called the Dorbs Beacon. It was specifically designed for observing meteors, and it produces an output power of about 150 watts at 50 megahertz, which is like a 6 metre wavelength. So you can see there are one or two reflections there. There's a reasonably large one towards the centre of the screen, just moving down our waterfall display, and a much larger one just entering at the top there. So you're seeing these reflections in real time, which is one of the reasons why we like to live stream these observations, because it's one of the few radio observations that you will actually see real-time data. So rather than us collecting data over a number of weeks, months, possibly even years, and then collating that together to show you a final result, this is something that happens live as we are speaking. So it's just a bit more exciting as observations go. We can't glean an awful lot of data from what we're seeing, only the frequency of the reflections. We can see that some meteors produce stronger reflections than others, but really doesn't have any bearing on the size of the meteor. And as I say, most of the meteors we're observing are really only about the size of a grain of sand. We call these micrometeors. Just switch back to our French radar system. So you can see it really kind of does vary, really, as to the results between France and Belgium. Around 2:30 this afternoon at the peak, we were seeing a whole flurry of activity, lots of bits of debris coming in, raining down on us from space. Now those streams have kind of weakened slightly. We're probably going to wrap up in the next 20 minutes or so. Most of the excitement was earlier this afternoon, and this stream will continue way into tomorrow and later into the week. But it will start to lose its yield, and we'll see slightly less reflections. Really do appreciate everybody who has joined us on our observation this afternoon. We really hope that you'll come back for future ones. Please subscribe to our page. If you're interested in our work, you can absolutely sign up as a supporting member. You'll find the membership form on our Facebook page. Also, if you live in the locality of Cambridgeshire and you're interested in volunteering, then please absolutely get in touch using the volunteering at email address, which I'm just going to share in the chat box here. Even if you're not local and you can't get to the Space Operations Centre, and anyway, due to the current COVID restrictions, a lot of our volunteers are working from home. So if you feel you have some skills or some experience that you could certainly contribute to our team, we're always interested in new volunteers. So please don't hesitate to get in touch. It'd be really great to hear from you. As I say, please subscribe on our page. Please follow us on all our social media channels. I'm going to let the stream run for another 15 minutes or so, and then we'll probably call it a day here at Aero. Again, thank you to everybody who's joined us. We really do appreciate your interest in what we do. Please go to our website, www.aero.org.uk, and learn more about us there. And I'll be back in about 15 minutes to wrap up. I'm going to leave you with the Graves radio screen. And we'll leave the audio on so you can hear the pings coming in. Many thanks. Really good to see you all, and extremely happy New Year. So, good afternoon to any viewers that are still with us. It's Jason Williams here from the East Anglian Astrophysical Research Organisation, ERO. We're just about to close up on our observation of the Quadrantids meteor shower today. It's been a really great afternoon, some really fantastic echoes received from meteors both above France and Belgium. Lots and lots of activity, really high yield. We'll probably be publishing some of our results over the next couple of weeks for anyone who's interested. Thank you again so much to everybody who's joined us this afternoon, everybody's input and everyone who's helped to make this afternoon's observation happen. I'm Jason Williams, Managing Director of ERO, the East Anglian Astrophysical Research Organisation, and now signing off and wishing everybody a pleasant evening. It's 18:02 UTC, and we're now closing down on the ERO Quadrantids meteor shower observation from the Space Operations Centre of the East Anglian Astrophysical Research Organisation based in Alconbury, Cambridgeshire, UK. Good night everybody, see you again soon.